in here. Okay. Have you guys all signed up for cisp300 or whatever class you have to sign up? Not yet?
December.
Oh, your priority is in December? Good luck. That's all I can say is good luck. It's really nasty. It's really brutal, now that we don't have that many classes to offer. So whenever the classes are offered, if you're not really high on the priority list, but at least you're taking one class this semester, so you'll still have priority over people who are not taking classes this semester. So it's going to be brutal. I mean, I can tell you that part already. Okay, two things that are really important. One is to finish up the Fibonacci number trace that we started on Tuesday. And the other one is to talk about your new homework assignment. Let's go ahead and talk about your new homework assignment first, because it is really not as difficult as the Fibonacci number. It has some of those elements, but not as difficult. So let me show you what it looks like, and then you guys can think about this while we talk about the Fibonacci number example. Okay, so this is your homework assignment. Your homework assignment is based on the return value, and it is also recursive. Except this time, the recursion is only here at one place instead of Fibonacci, which is two invocations on the return line, which is more difficult. So you look at subroutine S1. Subroutine S1 takes one parameter, which is n. If n equals to 0, it returns 0. If n does not equal to 0, you have to return the result of invoking S1 again, but this time you pass n minus 1 as the parameter. Whatever the invocation returns, you have to add 2 times n to it and then subtract 1 from it. That becomes the return value of this particular invocation. Yep.
Addition 2 plus times negative n minus 1 after that invoked subroutine has completed its job.
Yes.
Okay. Then you calculate the new value.
Yeah, same concept as what we have talked about so far. It's just the program. This is actually simpler than the program that we're dealing with Fibonacci. So this one is actually a little bit easier, but nonetheless, it is still recursive and it relies on return values. So this is a good test to see whether people truly understand the concepts of subroutine invocation, returning, and returning values in this case. Line 9 is the only invocation, so it should not take long. Okay, if you know the concepts already, the trace of this guy should be fairly short. But it does test all the major concepts that we have talked about so far. And you have more than a week to do it. Well, no, just a little bit less than a week. I make it due on Wednesday, which is the last day before the Thanksgiving break. Okay, it should be more than enough time. This class will meet again on next Tuesday. So there is the last chance for you guys to ask questions regarding this homework. Okay, so there's the homework, and this is binary search from my other class. I will close that. Close that. Close that. And now we can continue with where we left off last time, which is the Fibonacci trace. That was the 16th, yes. How many people did that? Finished the trace, or at least looked at the trace? Try is good. Okay, that's good.
I tried.
Very good. I think just looking at it and thinking about it is good. Okay, you don't have to finish it because that's the whole idea of the class. Is I will basically help you guys to finish the whole thing and explain everything along the way. But if you don't look at it, then now you have to look at it again and go like, okay, but what did we do two days ago? And by the way, I have updated the notes too from 2 days ago. Oh, I forgot to click it. Okay, let me show you what I mean by that. Okay, I have already talked about that. The subroutine nodes has been updated, and I have done some more updating. And there's one thing I have to ask for your opinion. Okay, this is one way of doing a trace and explaining the trace. In other words, I would use the column number as well as one column just for the explanation. Okay, the explanation will explain what is happening on the left-hand side. So this is the way I do it when I don't have too many columns in the trace itself, and I have a reasonable size for the explanation column. But sometimes, especially with return values, I don't have that much width for a dedicated column just for the explanation. So in the last one, I do it like this. If you look at row 12 of the trace, the top portion here is basically the trace itself, and then the explanation is here. So this way, I don't have to make it really wide, or I don't have to make the explanation to wrap around like 20 times. I think it looks better this way. It's easier to view with a smaller screen. I tried it on my cell phone. If I put my cell phone in portrait mode, I have to scroll, but if I put it into landscape mode, even on my cell phone, which does not have a big screen, I can fit the entire table, just doing vertical scrolling, but there's no need to do horizontal scrolling. So personally, I think this is better. But since you guys are the ones who have to read it, I will let you guys decide, do you want it to have its own column, or do you want it to be like this, especially when there are a lot of columns in the trace already. This is okay?
Yeah.
Okay. So I'll keep using this format when I have too many columns to begin with, and I will switch to have explanation having its own column when I don't have a whole lot of columns otherwise. Okay. I have to spend about 2 hours or so to kind of perfect the technique of making this happen, because I have to make it happen in the PDF as well as in the HTML format, and the typesetting program that I use is a little bit kind of touchy when it comes to this sort of stuff. Okay, any questions about this part? Comments? No? Okay, so you might want to read this part here, especially people who have not read it before. The example uses factorial, but it does illustrate the concepts that you need for the homework assignment, because factorial is defined like this. If n is less than or equal to 1, return a 1. Otherwise, you return n times the result of invoking factorial again, but this time with n minus 1 to specify n. In other words, this program in the notes bears a lot of resemblance to your homework assignment that is due next Wednesday. Okay. Yep.
On line number 6, you return n, multiply invoke factorial, and then n minus 1. What do you do that? Invoke factorial first, and then after?
You have to. There's no other way to do it.
Yeah. Okay.
Yep. Because until you invoke factorial n minus 1 and get a result back from that invocation, you don't know what to use to multiply by n.
No.
Okay. So it has to do with you have to resolve the unknown first. Then you can perform the multiplication. Then you can return that value back to the previous invocation of factorial. Okay. So that's that. I just want to point out resources that you can use over the weekend to do your homework. And now we can get back to Fibonacci and try to finish the whole trace. This is not the one that I want to look at. There are 2 versions of that because in my Monday, Wednesday class, we finished that already. So I have to just locate the right one from the zip file itself. Okay, this has to be the one that we have talked about on Tuesday. Okay, here we go. Okay, we are going to continue on row 22 of the trace. Now this is one thing about, yep, go ahead.
Okay, on row 20, it says return 1 plus 0. How did it become 0? I mean, if you scroll over to the right a little bit, it says n equals 0, but right above it says n minus 2, and n was 1. How did it become 0 with n minus 2 on row 15?
Okay, let's go back there. Okay, so the question is about row 20. The question is, how come this is now a 0? Let's go ahead and excuse me, look at the code of this trace. Okay, so we want to display the code, say over here, and then look at the trace. I have to scroll up a little bit. Okay, there we go. Okay, so the question is, why on row 20 of the trace we are replacing the question mark with a 0? That's the question, right? Okay, so the first thing we want to do is to look at the line number. Which line exactly are we executing to get to that result? Okay, this is our line number. This is line number 4 in the pseudocode. Line number 4 in the pseudocode is a return statement. In fact, it is just returning a constant of 0, right?
Yeah.
What do we do when we execute a return statement? We copy and paste the return info cell, we locate a question mark, we replace the question mark with the value that we are returning, right? So that means, on row 20 of the trace, we copy and paste G18 to here, we locate the question mark, we replace it with a 0, and that's what we did.
How did, going backwards, it says n equals 0, and this wouldn't happen if n equals 0, but how did n equal 0 when n was 1 in row 15 with an n minus
Because
3?
it was invoked again. This was invoked again on line 8, but line 8 at that point looks like this.
But n was 1 earlier, now it invoked f n minus
That's
3.
because when we invoke f with n minus 2 to specify n,
Yeah.
that n is column f, which is 2. 2 minus 2 is 0.
So it isn't the next column over. Why isn't it the next n column over where n equals 1?
Because this is the code, but it does not execute in the context of column G and H. At this point of the trace, on row 15 of the trace, all we are doing is to resolve what this question mark should become.
Okay.
But we are not executing line 8, we are executing line 6 in this case. Okay?
So return 1, but
Okay, hold on a sec. Look, now, hold on. After line 6, what do we do? Line 6 is just changing the question mark to a 1.
okay.
After line 6, we get out of the conditional statement. We get to the end of the subroutine. So we get to line 10. Line 10 is the end of a subroutine. We always do the same thing at the end of a subroutine. We deallocate all the columns that we allocated for that invocation, and then we use return info to tell us where to go back to, right? Now, return info in this case tells us to go back to line 8. But not only that, if I just want to know which line to go back to, I would have used return line number. Return info tells me not only which line I'm going back to, but how that line looks like at this point. So that means on row 16 of the trace, line 8 is effectively like this. Return 1 plus invoke f n minus 2 goes to n. I cannot do the addition yet because I don't know what the second invoke is going to return. And as a result, I have to invoke again on line 8, which is row 17 of the trace. Okay? But when I invoke again with n minus 2 going to specify n, the n minus 2 or the n of n minus 2 on the left-hand side is going to use column f, which has a value of 2.
Why did they use column F and not column 8?
Because I am executing line 8 in the context of column E and F. Column G and H are deallocated at this point.
Oh, okay.
Okay, so I know it looks confusing, but you have to kind of remember how we do things. A return statement, for one thing, only replaces the question mark with a particular value. It does not execute the statement in the return info cell. Okay, when we return, then we return back to that